Hi, and welcome to our second video on the modulus function, and in this video we're going to be looking at doing some solving equations. Now, in order to understand what's going on with the solving equations, you really do need to have your head around all the sketching, so please make sure that you've spent some time sketching graphs of modulus functions so you understand what's going on with those, because that is going to be a big help when it comes to understanding how we go about solving these. Right, so here we go. Let's do some equation solving. So we've got three there to have a go at. And the way to approach these things is to, first of all, think about your sketching, and in particular, two things you've got to be very careful with. First is the point of intersection with the axes, particularly where it intersects with the x-axis, and secondly, the relative gradients of the lines, i.e. how the gradient of one function interacts or relates to the gradient of another one, and we'll see that in these examples. So, here we go, part A. So, first thing I'm going to do is have a go at my sketch. So, this is going to be the sketch of mod 3x plus 2, and hopefully comfortably it looks like that. And then I've got my other graph, which is minus half x plus 1. So again, intercepts for both, so I'm comfortable and know what's going on with them. And this one's fairly straightforward, because what you see now is what we've got is 2 points where these lines intersect. Now, that first one is when 3x plus 2 equals minus half x plus 1. So because this is just the normal kind of what I refer to as being the positive arm of this modular function. Nothing weird is going on with that one. It's just straightforward, so we've got to solve this equation. So let's do that. Solve that. We end up with x equals minus 2/7. That one's fairly straightforward. The next thing we've got to do is have a think about this point up here. So in order to be able to find that point there, we've got to go back to our definition of the modulus, and this is why I made such a thing about this definition in the previous video. Because what we're saying is, if our definition says if x is less than 0, then mod x is minus x. And if we adapt this for the function we're looking at, what we're saying now is, if 3x plus 2 is less than 0, which it would have been kind of down here, what we do is take the minus version of that. And that's the thing that flips it back up to being up here. So what that means is, in order to find this point here, we've got to put the blue line, minus half x plus 1, equal to the minus version of 3x plus 2. So, what that looks like would be that. And that's why that technical definition is important. So, what I'm looking at here is, I see these, as I said before, as being this one here being my positive arm, this one here being what I refer to as the negative arm, and so I know I've got a point of intersection with my negative arm meets my blue line, which is that equation. Do some solving on that, and we get x equals minus 6/5. So those are our 2 points of intersection. Now in this particular question, we're talking about an inequality. We want to know where the modulus function is less than minus half x plus 1. So that's essentially when the blue line is above the red line. So we've got to be in between our two values. So that tells us our inequality, or our range of solutions, is x is greater than minus 6/5 and less than minus 2/7. So there we go. Right, on we go, part B. In this case, we've got the modulus function around both parts. We've got two moduluses, whatever. We've got two of them to deal with. So there we go. So there's the first one, 2x minus 1. That's that one. And for the second one, I need the sketch of y equals mod x plus 4. So there's y equals x plus 4. Flip the negative bit upwards, there we go, and that's y equals mod x plus 4 that's there. And this is what I'm talking about. This sketch is vital in terms of understanding where these points are relative to each other and what's going on with the relative gradients of the lines. And let's have a look at what's happening now. So the first point of intersection is where the positive arm of mod 2x minus 1 meets the positive arm of mod x plus 4. So that one's straightforward. That's that equation we've got to solve. The second point of intersection is, now this time it's the negative arm of y equals 2x minus 1 is meeting the positive arm of x plus 4. So for that one, we've got that equation, and that's why we've got to take the negative arm, and that's why it's important we understand what's going on with these points here, where they are relative to each other and what's going on with gradients. And of course, if we take kind of the third option, if we look at the kind of the two negative arms, well, we know those two negative arms are never going to meet, and the reason is that this one here has got a steeper gradient than this one over here. So we're safe in the knowledge that those two bits are never going to meet. So what our sketch does is allows us to think about which version of which arm of which function intersects with the other one. So, and having that diagrammatically makes it a lot more straightforward, because it's not always obvious just from looking at the equation. I don't think I'd be able to look at that equation and tell you exactly what's going on every single time. So, what we've got is two equations to solve, one for each point of intersection. So let's now do that. Let's do the solving. So on the left hand side there, we've got a value of x equals 5. That would be our point up here. And from this one here, we've got a value of x equals minus 1, which would be that point there. So there we go. There's our two solutions to our equation. Mod 2x minus 1 equals mod x plus 4. Right, so that's part B done. On we go to part C. So this time what we've done is adjusted a little bit what's going on, and again, same issue I've highlighted in other videos or other parts of the video, in that we've kind of jiggled around a little bit about where the modulus is going. And again, for me personally, other people might do it differently. I personally prefer to get just a modulus on the left and chuck everything else over onto the right hand side. So with just what I'm able to do is just get this bit here, the modulus on the left, and everything else out of the way. So here we go. So we've got 3 mod x minus 2 minus 5. So let's do a bit of rearranging. Take the 5 over. Now do the dividing by 3. And that's just left me with essentially the modulus as the subject on this left hand side. All I've got to do now is do my sketch. So here we go. So there's the mod x minus 2, our negative bits flipped up. So that's that bit. And then we've just got to sketch 4/3 x minus 2/3. So that's going there. I did a bit of solving to figure out that my point where the blue line hits the y-axis is to the left of where this line hits the y-axis. So we've got a value of half there. And straight away I'm looking at it thinking, well, that tells me immediately that I've only got one point of intersection. So we can just crack on as we did before. There's my point of intersection, and it's where the blue line, 4/3 x minus 2/3, hits the negative arm of our modulus function. And again, I know that this bit here is never going to hit this positive arm because I've got a steeper gradient, which is 4/3 here. Gradient of this bit is 1. So these two lines are going away from each other. So they're never going to hit. So I know I've only got the one point of intersection. So I've got one equation to solve. And the equation I've got to solve is that one, where it's the negative arm is hitting there. And now I can just do a bit of solving equations. And we end up with my value of x equals 8/7. Okay, so that's there really to emphasize issues surrounding kind of the modulus, issues surrounding relative gradients, relative points of intersection with the x-axis, and the importance of understanding what's going on with those two functions. Again, as I said previously, you can make your life a whole lot easier if you've got a graphical calculator, because your graphical calculator can just plot this for you. You can see straight away what's going on. You'll find your graphical calculator will find a minimum point for you. It will find points of intersection for you. It will do all that stuff for you. And you might think, well, you know what, why do I need to know the basics if I've got a calculator? Please, please always bear in mind that the examiners know you've got a graphical calculator, know it will do a lot of that for you, and they will find ways to examine your knowledge that gets around the issue of having a graphical calculator. So it's important you're using your calculator throughout this whole section as a checker rather than making it do all the work for you. Right, on we go. So here's an exam style question. So what we're going to do to begin with is do a sketch. And it says there clearly all points of intersection with the x-axis have got to be on the sketch. Then we've got a question about the range of a function. And then finally we've got this idea of these two distinct routes for solving the equation where f of x, our function, that's this function here, is equal to minus half x plus c. And we've got to figure out what is the value of c. So on we go, part 1, here we go, sketch of the graph. Now we've seen this before, and again I tend to treat these as a combination of transformations. So first of all, my sketch of y equals mod x minus 4. There it is. Hopefully we're fairly comfortable with that one now. Then we've got to do the stretch. So let's stretch it in the vertical direction, scale factor of 2. So that's going to be that. And now you'll notice that my y-intercept is at 8. And then finally we've got the last button here, which is this minus 5, which is a vertical shift of 5 units. There we go. And then all I've got to do now is work out where my points of intersection are. So where my positive arm is going to intersect with the x-axis. So that's that one. Solve that, we get x is 13/2. And then where my negative arm intersects with the x-axis, which is that. And you'll notice the minus here is minus just that bit. I'm not changing the sign of this bit over here. And if we solve that equation, we end up with x is 3 over 2. And so there you go. There's my complete sketch. On we go. Now, it might be on a sketch that normally I would have clearly identified also where the minimum point is because we're going to be using this. So let's just have a think about what's happening there. Well, this one's fairly straightforward. The minimum point is going to be at 4 minus 5 because if you remember we had 2 mod x minus 4 was kind of up here and it just shifted down 5 units. So I've got a minimum point at minus 5, which means the range has got to be f of x is equal to or greater than minus 5. Right, on we go, part 3. So we've got an equation where we've got 2 distinct roots, find a set of possible values for c. So what I'm going to do is put on my line, so there's my line y equals minus half x plus c. So for some value, c would be this point of intersection here. And we've got 2 distinct roots here. And we're always going to have 2 distinct roots when the line is up here. But if we now just say, let's imagine just reducing that value of c. Reducing c would just kind of drop that line down. And so we get to that point there. And at this point here, we've got 1 root. So for any value of c that's above here, we're going to get 2 distinct roots. So we really need to know what is the value of c that makes my line here. This just kind of hits the minimum point there. And there's 2 ways of going about this. First one I'm going to do is that and put the 2 things equal to each other, as might be fairly obvious. So now if we say, well, let's solve the equation, and what I'm doing here is saying let's imagine it's hitting the positive arm. If I tidy this up, we've got that, but the problem I've got is I've still got 2 variables, and you should know by now that if you've got 2 variables, you need 2 equations. So let's put it equal to the negative arm as well. And so now I've got 2 equations, and let's bring those 2 things together and solve them simultaneously. So there you go. That gives you a value of c equals minus 3. So that was kind of the first, my instinctive approach to that would be to put the 2 equations equal to each other. But it generated a bit of work in a simultaneous equation, so I kind of think that that way of doing things is a little bit like taking a sledgehammer to crack a nut. So I had a bit of a think and came up with another way of doing it, which was to do this and say, well, if we've got c as this intercept here, so this blue line here has got to go through the point 4 minus 5. And so if it goes through the point 4 minus 5, all I've got to do now is put those values into my equation, and that then spits out a value of c equals minus 3. And like I say, I've got to be honest, when I put this PowerPoint together, this was my second approach, and there's often more than one way of doing things. Both methods work, but clearly you can see that this idea here was a whole lot more simple, so I kind of wish I'd come up with this one first of all. But there you go. You've got same solution, c is equal to or greater than minus 3. And there you go. Exam question nailed.